So this is problem 38, chapter 13, Giancoli 6th edition. So we have a tire. Okay, before doing anything, try to remember when we are thinking about a tire, we are thinking about an object that is not really changing its volume. Okay, so we have this tire, and whatever is going to happen to it, the volume is not really going to change. The amount that it changes is minimum, so it's going to be negligible. Okay, this is not, all this that I just said is not said in the problem, but that's what you can assume. And this tire is completely filled with air at this initial temperature, I'll call it T1, which is 15 Celsius. Remember, when you're using this equation PV equals nRT, you have to convert the temperature to Kelvin, so do that before anything else. Write this temperature in Kelvin. All right. And initially, this tire has a certain gauge pressure. Remember, we always play with absolute pressure, so I'm going to write this pressure as the absolute pressure, which is whatever number they gave us there, plus 101.3 kilopascal. Okay, so they give us the number in kilopascal. So probably each person has a different number. I'll put it like this. Okay, so this is the absolute pressure. What else do they tell us? Well, that the temperature will increase. This temperature will increase and will now become 36 or a higher value, 38 Celsius. Okay, according to the book, it's becoming 38 Celsius. You may have a different value in your problem. And so let's write this again in Kelvin. Very good. And what we expect is that the pressure will increase. The pressure will increase, but what are we going to do? We want, so I'm going to put here, we want the pressure to be kept fixed. Okay? So we want the pressure, the P2, to be equal to the P1. So how can we get that? If this temperature increase, the volume is constant, how can we possibly have the same pressure? Well, this is only possible if I open the tire a little bit and let some of the air move away. Okay, so I need to remove part of this air. And the question is, what fraction of the original air must be removed if I want this pressure not to change? Okay. All right, so let's think a little bit about this. I'm going to say that initially we have a certain N1, certain number of mole for this gas, and now we'll have a certain new N2, which is smaller than N1. Okay. What is the fraction N2 divided by N1? Okay. Well, I can compute that. How can I compute this fraction first? Well, for this original scenario, what we have is that P1 V1 is equal to N1 R T1. Okay, this is that's what we're assuming here, that we have an ideal gas. And later on, at a higher temperature, we have P2, but P2 doesn't change. I'll call it P2, but I know that's equal to P1. And then we have V2. V2 also doesn't change, but what does really change? N2. R is just a constant, and T2 really changes. Okay, so I know that this and this, and this do not change. So let me rewrite this equation. P1 V1 over R is a constant. What changes is N1 and T1. P2 V2 and R is constant. What changes? N2 and T2. Okay, so let me put this together. This and this are equal. Okay, so this means that N1 T1 is equal to N2 T2. That's the only way that we can keep this pressure constant. Okay, so this is the equation that we are going to play with. From this equation, I can find the fraction between this new amount that I have divided by the original one. Okay, but this is not really the question of the problem. What they want to know is what fraction of the original air must be removed. Okay, this is what we have. But we want to know what is the fraction that has to be removed. So we want to know what is 1 minus n2 divided by n1. This is the fraction of the original air that is removed. Okay, so let me repeat. This is the fraction that I now have. Okay, the new n2 divided by the original. But how much did I remove? 1 minus n2 over n1. Now 1 meaning here the original total n1. Okay. If you don't understand what is being done here, let's try to write this in another way. How much do we have to remove? How much air do we remove? We remove from n1. We remove um, so the original one is n1, the final one is n2, so this is n1 minus n2 is how much removed. But we want to know what is the fraction of that. So what is the fraction of the original? So what we want to compute is n1 minus n2. This is what we removed with respect to the original. Okay? So you see that this is 1 minus n2 divided by n1. So maybe in this way it gets easier to understand this fraction that we are computing.